we got some very interesting. Had building experts, and we were getting some very interesting feedback that the regulations weren't of themselves clear enough. But every regulator knew that there was a British standard that talked about this, and so they knew stuff, and so we had to try and capture some of that external knowledge as well. You can't always look at well, as an outsider, you can't look at the regulation and necessarily understand what it really means, because there's a lot of tacit knowledge that architects have and regulators have. It's never been written down. Like, go and look at the British standard on contrast on wall colours and so on. So we got some very, by saying we were going to look at everything, we started to find out some very interesting details. Also in the UK, the building inspector also goes on site, and some things they just say, we'll check it on site. So because that depends on paint colours and so on, they said we'll postpone that to actually when it's built, with some risks attached to it and so on. So I think that's interesting. But in the end, we are going to end up with lists of properties that need to be in the model, either because they influence the requirements or because they influence the applicability of those requirements. So in my example of the door, we had to document not only the pull strength of the door and whether it could automatically open, but also that clause only applied to main doors on the perimeter of the building, and so on. So we have to capture the properties or the geometry or the situations that determine whether a regulation applies and the requirement. And what really interesting was the exceptions. Because I think when people are setting information requirements, they make long lists. You shall do this, you shall do this, you shall do properties on it. What makes regulations much more complicated is that they have exceptions in there, that they have selections. The regulation may talk about openings, and we know that means doors and windows. And so there isn't always a match between the language in the regulation and the language in the BIM, and so on. So yeah, we've got a set of ideas which I think could accelerate your project with some comparisons and so on. But is Tomi available now? Yeah. Okay, so I think
yes.
Really an example. Hi Tomi, yes, we hear you.
Yes.
Okay.
Finally.
Yep. Anyway, thank you. I think it was a good introduction to the things that we're wanting to try and deal with in the regulatory information project. It'd be great to hand over to Tomi now and to get an update on the project.
Yes, I will start by explaining what we are aiming. So I was not able to follow in detail the presentation since there was no sound, but just heard kind of Nick's words at the end. And I think it kind of explains what we are aiming. And today we are, at least in the second session, maybe today in the first session as well, but we are quite technical phase in the project, and this also the things that we are showing today might seem to be really technical, but that's why I wanted to show this diagram which tries to explain what kind of different levels there are in the project. And if we start like building a house, you start with the foundations. If we start from the bottom, we have the IFC data schema, which is of course already there. We don't necessarily we don't need to modify that, or maybe we are good with maybe we can live with the information or the entities and properties and property sets which are already in the data schema. Well, today we already know that there are probably some things that need to be added to the data schema. It's always difficult to add elements, and we try to avoid that. But properties shouldn't be that difficult, and probably that is one of the outcomes of this project, that we come up with additional properties and property sets that need to be added to the IFC standard. But anyway, we have the foundation there. It's pretty solid, I would say, and we can work, and we can have the building permits and the building permit process carried out using the IFC data schema. On top of that, we have property sets. They can be local, or they can be IFC property sets. I'm showing today the study, what we have done, or the phase of the project. We have tried to we have some property sets from Finland and Sweden, from Finland and Estonia, and we have tried to combine those or compare those and see if we can deliver those same properties using just IFC standard properties. But those should be so this is the level where we want to probably introduce new properties, or if we need to. Well, at this point, I can also already tell that probably we need to add some or introduce additional properties to IFC. Then we have classification and coding. This is really local, I would say. In IFC, those are typically handled by enumerations. In some cases, they work well. In some entities, in other entities, they don't work that well. But anyway, if we go to classifications, they are definitely local, and the RIR project is not going to specify and introduce a international coding classification system. That is totally out of scope, and I would say that it would be quite impossible. But those are kind of the three bottom layers. They are kind of the technical layer, and in order to move forward, we first need to study that. Then once we have the technical layer solid, or it doesn't have to be finalized, but we need to have some kind of technical foundations that we can build on top of. And then we can start defining the use cases. And I will explain today what I mean by use cases. When I'm talking about use cases, I'm following more or less the ISO 2941 part 1, which is actually the standard is originating to buildingSMART. So this was a buildingSMART project about 15 years ago, which then was introduced as a ISO standard and published 2011 original version of the 2941. So I'm talking about information delivery manual or manuals. That's the name of the standard. And in the first version, it was quite, let's say, IFC oriented. It was developed by a group of buildingSMART active people from buildingSMART, and it had really the scope was more or less. I think that it didn't say anything about IFC, but if you read the standard, you can kind of understand that, okay, this is all about IFC. But then there was a second version that came out 2016, so revised version from ISO, and now it's more, and this is still the current version, and it's no longer a IFC specific standard. So you can basically use the information delivery manual standard to specify any kind of information delivery manual. Yeah, I will come back to that a bit later in detail. But those use cases, they specify the purpose. If the technical layer is just a technical layer, it has property sets and properties, and we have an address where we put the information. But use case specifies what information we are going to put there and how it's going to be used, maybe. So the technical layer doesn't specify the purposes, but the use case, they specify the purposes. And then on top of that, the highest level, we have guidelines. And these can be quite kind of not abstract, but high level, just explaining the general processes or general needs of, for example, in this case, building permits and regulatory use. And this is also, of course, when we are talking about regulatory processes and building permits, those guidelines, they can be even global ones. They can be based on different international standards. We can use the ISO 29911 framework for these guidelines. We can connect the kind of the concepts to ISO 19650 concepts and so on. So there is kind of tools and other kind of standards, or maybe we're not specifying standards here, but there are kind of other documentations that we connect to. But and this is something also that can be done within regulatory room, but maybe not in this regulatory information requirements project. Then I have, okay, I have accidentally removed my slide, but no worries, I have somewhere. I think I had some. Okay, I will come back to specify use case. I'll try to find this the slide. But the scope and the kind of main use cases, maybe that's not correct, the fine term, but kind of the big picture, that what we are concentrating on. We have kind of the concept and zonal approvals, the technical design and construction approvals, and then approvals for occupation and use. So basically 3 phases. Yesterday we were looking at our roadmap, and if I just show you, if you were not attending the sessions yesterday, so here is our the different phases, and these are from a study that Masaki Muto conducted to regulatory room some years ago, and he found out in this white paper or study, it was identified there are kind of 6 globally common phases. Of course, all countries are not going through all the phases, but they are kind of you can see that, for example, in Finland we have the concept approval, technical approval, and construction approval. They are basically one process. Each of those steps are still in the process, but you don't get 3 approvals. You get just 1 approval, but you need to kind of pass these 3 phases. But so it a little bit varies country to country, but the general concept is like this. So what we are doing here, we are checking out the concept approval, and then we have the technical approval, and then the handover. So occupation to occupation and use of the building. So those are the scopes that we are focusing in this one. Approvals for occupation and use. But then how to eat an elephant? Those three main topics here, the main use cases. They are rather large ones, and when we start specifying the use cases, because use cases in use cases, if we follow the ISO 2941, the IDM information delivery manual standard, in the use case you specify 3 main topics. You have the actual purpose, where you identify the actors, contractual things, maybe other regulations, kind of prerequisites for the use case. In the second part, you specify the processes, and very important part of specifying the process or processes. It can be several processes. Is to specify the roles and responsibilities. So who delivers information to whom? Who delivers the initial information? For example, if we have an architect who is applying for a building permit, and there is fire, the use case is something like fire escape routes, then where does the initial information come from this for this use case, for this information that the architect is specifying? So the process is not only like a diagram showing that, okay, the information flow is like this, but it's also specifying the responsibilities for different actors. And I would say that from the second part, maybe that is the biggest, kind of the most important outcome from the second part. The third part, of course, that's the beef. That's the piece of the elephant. That's the most important part. That's the exchange requirement. So what information needs to be exchanged in order to fulfill the purpose specified in the first part of the use case? The information can be geometrical, so you need to specify what is the level of the information, how detailed it is it parametric or all that. So geometrical proportions. alphanumerical proportions, which is the property sets and properties which we're working, the coding, maybe even classification if it's local ones. So all the information which is needed to exchange in order to fulfill the purpose. And the third part is additional documentation. Maybe it's an operational manual that needs to be attached to the information or to the information exchange. So these three parts together, they form up the exchange requirements. So geometrical, alphanumerical, and documentation. So that's how we specify the use case. And it is a big job. If we start from, for example, from technical design and construction approvals, first of all, it's several different models. We have typically the architectural model, but then we might have the structural model, the HVAC model, maybe electrical model. So we have several different models, and there is a huge amount of entities in the models. There's huge amount of information in the models. So if you try to specify that as a one use case, I'm pretty sure that you will fail. So how do we do this? We cut it to pieces. So we identify sub-use cases. The first one, which we have already started to do in the project, is the project information and identification, which covers pretty much the scope of the from the previous application forms project that the regulatory room did some years ago. But of course, now as we are kind of going to quite practical level, since we have a couple of countries who are already kind of testing and piloting this, so now we have maybe a bit more like practical information. So we are collecting information from the site, from the building itself, from the usage, maybe historical classes, location, which is a pain. It's really pain, but we need to sort it out one way or the other. Zones with usage and areas, and this is also quite, I would say, not complex, but we have only basically we have very few objects, entities in IFC to represent the spaces and zones. So we have the IFC space, then we have the in the IFC4 the IFC spatial zone, and then we have the old IFC zone. And those are our kind of tools that we need to operate with. And if we think at how many different types of zones, area types, total areas, site areas, buildable areas, room areas, all these different types. We have parking lots, we have balconies, you name it. So we have different types of areas and spaces, and then we have only 3 types of objects, which are actually, we have 2 usable objects: the IFC spatial zone and IFC zone, IFC space. Okay, that will be challenging, I would say. Then we have the systems and services, and maybe Nick, if you start, do you have the slide where you explain the spatial aspects, the project aspects, and then the object aspects or product aspects?
I don't have the slide, but I can do a quick sketch. And I think it might help people understand a little bit more about the IFC as a target.
Yeah. I
And
might have that also somewhere, so maybe I can try to find it out. But
and this is where I have to admit, although I trained as an architect, I can't draw. One of the things that people don't always understand about the IFC is that it has a very broad scope. You can describe a lot of things, and currently it's not. Only some small parts of it are used. But if you want to understand the full scope, I make a diagram in 3 parts. And the first one is about the spatial aspects. Now, the great thing about spatial stuff is that we live in spaces, whether indoors or outside. These are the things that really matter, because we do productive things like have meetings in spaces. And what the IFC does is say, well, that starts with the site, which is probably the biggest thing that we normally deal with. And we usually end up breaking down the site into spaces. They can be indoor spaces, they can be outdoor spaces. Now let me say something about the physical stuff, the stuff you can actually kick. The physical stuff normally starts with an idea of a building, or if we're talking about a facility, but I'll put building in here now. And if we break down a building enough, we end up talking about individual elements, or let's call them elements. Sometimes called components, sometimes called
And not physical, it ends with parts, right?
parts. Yeah, okay, so parts. There is a third aspect of what the IFC can discuss, which is about process. And it's not much used in the main discussions. If you go to the construction room, obviously they talk a lot about process. But at the top of that, we have something called either a project, or if it's a building in use, we might talk about the program to look after it whilst it's being used. And at the very bottom, we have lots of individual tasks that need to be carried out. And if we take the big picture, that could be design tasks or individual construction steps like digging a hole or pouring some concrete, or it could be a maintenance task like inspecting a lift or whatever. Now, there are a lot of spaces, a huge number of tasks, and a fair number of elements, and so we need to manage them. And so what the IFC does is to say, to help manage the spaces, we will have, zones. And as Tomi said, we can have zones for public space and private space and escorted space, and so on. We can have zones that represent apartments, we can have zones that represent fire compartments, and so on. To make all these elements manageable, the main thing we do is we divide the building up into systems. And the reason we do that is we don't want to buy and put elements into a building unless they're there for a reason. And it's usually that things are there for go into a system. It may be a structural system, it may be an external envelope system, or it may be a lighting system. And just to complete this pattern, in practice, tasks are made up into packages. And you might call them responsibilities or duties, but we assign them to whole numbers of tasks to either people or organizations. That still makes it very hard to manage. And so there's another way of this. I think of this as the management layer. And the other thing we do with spaces is we have space types. Now, we're not very good at talking about space types. We talk about the individual rooms, but around here, there are 10 conference rooms, and they all have the same specification. They all have the same classification, They all have the same carpet, I've noticed. So we use space types to help manage spaces. Of course, when we're buying stuff, we have things called products, which we buy, or types. And a lot of the effort of design and construction and management is developing these product specifications. Because there are just too many elements to think about. So we have this product type, idea, can be catalogs, can be of stuff. Sometimes it's got nothing to do with purchasing. You know, we don't buy slabs of concrete or something, but we don't always buy slabs of concrete. We just build them. But, so it's products, it's specifications, it's groupings. And just for the record, over on the process side, we have types of tasks or method statements is the term that's used in construction and in maintenance. We have method statements, how a certain task should be carried out. Let me just call it methods here. And so on. Now, what the IFC does is it gives us all of these kinds of things and it helps us relate them together. So when Tomi was talking about what entities, what geometry, we can say some of these things have geometry. The site, the building, the products, the elements, probably the spaces will have geometry too. When we're talking about attributes, any of these things can have attributes, and any of these things can have documentation attached to them. The other thing that doesn't get mentioned very often is that the IFC tracks relationships. I've got grandchildren, and they get the Duplo box, and it's a pile of bricks, and it's not a building because they haven't learned to put the bricks into a relationship with each other. And it's actually the relationships that make the built environment interesting. So there are connections like tasks, affect elements. Elements are inside spaces or bound spaces, and I could cover this with diagram arrows representing different relationships. What that means is that whatever regulation we're trying to think about, we will end up trying to extract bits of information from this and their relationships and selecting on them according to what properties they have and making decisions. And that makes us fairly confident that we can actually capture any regulation in any form, because it will always have something to do with these 12 objects. And so that's our foundation. This is, when I walk along the street, this is how I see the world, because I've been doing IFC for 20 years. But what it means is that I'm confident that as we go through the Regulatory Information Requirements Project, we will probably have all the objects we need in the IFC schema already. What makes the regulatory process challenging is that we need to know very specifically things about an external door. We need to know some very specific things about a corridor, if it's an escape corridor. And so that's why the emphasis is very much on the properties, because we've got the entities, we've got the relationships, we just need to fill in those details. There is a much prettier version of this picture. But I hope that, I mean, that's how I explain why IFC is the right answer for what we're doing, and why Tomi and I can be confident that we can answer some of the questions in the Regulatory Information Requirements Project, because much of it will come down to just what attributes do we need to attach to these to answer regulatory questions. Yes?
This structure is contained IFC hierarchy already, you mean?
Well, there's a slightly more complicated one because spaces get bound into apartments or suites or building stories. Elements get grouped into assemblies, and technically, the industry is very unstable about what counts as a product and what counts as an assembly. There are people who are trying to move more and more of the industry into factories, off-site manufacturing, and so you get massive assemblies. In other situations, there's an extra layer, and similarly with tasks, but I won't get into that. So you can refine this diagram, and but the power of it like this is that most of the things you'll find in regulations are talking about one of these things and what's expected of them.
I agree with you. So it's a very good arrangement for the right side is very conceptual, and the left side is conceptual. The right side is the occupational phases.
Yeah.
It's a very good arrangement. For,
Yeah. Okay. There are some things down here that don't get to mention. They're called people. And people do tasks, they occupy spaces, and they damage products and so on. So there are people in this diagram somewhere, but we don't regulate them. Okay, Tomi, was that the diagram you had in mind?
Not the latest one. You have developed it a little bit further, but basically the same concept. So I found the slide.
That's so much neater. But, and you can see the words change sometimes. You know, we've got events instead of tasks. The word duties instead of packages. Even just within English, we use lots of different words for things.
Where's the common language?
I'll tackle world peace because that will be easier than sorting out all the language issues we have in the industry.
Different project processes.
It is
Different.
But this is really important diagram for the work that we are doing. We are focusing into this part here. Sorry. So this middle part. So this is basically well, we could say the space, of course. These two. We are not that much in the regulatory information requirements project. We are not that much focusing into process things, but of course it might interfere or it might reflect to the actual. So, and now at this point we have been kind of studying the middle part, the kind of the elements, the physical elements and their digital, maybe you shouldn't call them twins. Maybe they are something like cousins, or but yeah. But anyway, so but in order to understand the kind of the technical part that we have been doing, it's quite important thing to understand this diagram. I actually took this so far that I have worked as a consultant for the Finnish government, and I took this diagram and I have now specified the whole regulatory system here in Finland based on this diagram. So the whole not whole regulatory system, but the part that is using IFC. So when we are talking about BIM in regulatory processes here in Finland, it's pretty much based on this diagram. So now I can, if everything fails, I can blame Nick. Yeah. Bit further, we have other pieces of the elephant, so to speak. the life safety, of course, rather important. I would say that the whole building permitting, there's three major elements in building permitting, or major kind of goals with building permitting: health, safety, and then politics. And politics is, of course, city planning. So basically, the authority checks that the building is in the right location in the site. It's the right size. It's right type, and that's all politics. And then once this is checked, then he or she can check the health and safety things. But those are basically three. At least this is. I have simplified this maybe quite a lot, but this is how it works, in my mind at least. Then we have the third, and of course this is a very hot topic: the building performance. There's the carbon footprint that we discussed already yesterday, but maybe these things are connected together. So we have different systems, different sources of energy, consumption of energy, how the building impacts the environment. The carbon footprint can be, or the carbon calculation in general can be divided into life cycle carbon and then embedded carbon. I think that if you ask me, in this project, we are focusing into embedded carbon. That's something that we can specify using IFC entities. The life cycle carbon is a bit more difficult. Of course, IFC has all these process entities, but they are not that much used. And the demolition of waste, of course, that's also belonging to the whole. So this is what we are doing, and I go back to the first diagram. So far in the project, we have been focusing into the technical layers. So these three bottom boxes here. So studying IFC, understanding the limitations of IFC, and at the same time looking at the needs. Of course, we have those titles for these use cases. So even though we haven't really specified the use cases yet, we still know, we already know that we need, for example, for fire safety, we will need, every entity needs to have a fire rating, of course, in order to fulfill that. So we need kind of basic stuff, even though we haven't really started to develop the use cases or specifying the use cases. So this is where we are. Maybe is there any questions, comments? I think that we are heading for the pause. So maybe I should not start the technical part yet.
Okay. Any comments on what you've heard so far? Well, I hope you can see the connection between what you talked about and particularly focusing on those three use cases: the city planning or the overall context, the life safety, and then I wrote down the third was environment, and then I crossed that out, and it's really just waste. It's all different ways that we waste in our buildings and so on. We know that there are some other topics which we probably won't get into. In the UK, we have some amazingly complicated regulations about plumbing, because for centuries we got it all wrong, and so we have a whole section on the right ways of doing plumbing, and similar things. But I think the ones that we're focusing on are the ones that designers and architects, designers and regulators are most concerned with. Occasionally we get hints that the regulators don't check the regulations they don't think are important. There was a very interesting study done in the USA where they took a design for a supermarket and they gave it to 8 different jurisdictions to check, and all 8 came back with different issues with the building, but none of them spotted that the fire escapes didn't go anywhere. And that was, that's one of the reasons why I'm keen that we shouldn't be too picky about which regulations we try and automate, because the pragmatics that you hear that people are taking, the shortcuts, the heuristics, they don't end well. I spoke to one jurisdiction in the USA, and I said, when you get a new scheme, what's the first thing you do? And they said, we look at the name of the architect, because we know what mistakes that architect is most likely to make and stuff. So they have their heuristics. But when we're starting to think about automation, I think we have to try and be as complete as possible. I've heard building control officers, as they're called in the UK, saying, we don't check the disability regulations, the access regulations, because no one's going to die because they can't get a wheelchair around the corner. I was quite shocked there, because our government has passed, when we had a government, a piece of legislation saying that this should be covered. And it was quite shocking to then find that some building control officers were saying, well, we can't be bothered with that. We don't. So, yeah. Any comments on the scope that we've outlined?
We actually had a challenge in one of our jurisdictions in Canada that was a human rights violation. Accessibility to move around the built environment was hampered. So, I'm a structural engineer. We focus a lot on life safety, but we can't say one thing is more important than the other. But I think you can capture that through different use cases and different levels of modeling to reflect those use cases of what things are you checking for. And as we phase this in, what will the building authorities actually have confidence in the electronic checking, and what will they still do manually themselves anyway? While I've interrupted, I have a question, which is this predicated on taking a regulation that's written on paper or stone tablets and putting it into some sort of rules engine with the brute force of technically knowledgeable people?
Well, this project is focused on identifying the information that's most likely to be required. We have in the room and people with a lot of experience of the automation technology. Edward outlined an approach of converting getting experts to take the legislation and convert it into, I think it was an XML structure representing rules. And there is probably a dozen different approaches like that. And all depend on someone doing an interpretation and making it a machine interpreter.
So my corollary question is, sitting alongside the authors of the National Building Code of Canada, if the folks in the room could wave a magic wand and have the authors write it differently, how would we change our approach to writing regulations to better enable connection with these systems?
I think one of the standards that was listed on one of Tomi's charts is an ISO standard called ISO 12911. And its actual title is Writing BIM Implementation Specifications. But if you look at it, you'll find that actually it's a recipe for how to write good requirements. And I think, well, my experience is that first of all, you have to cover 4 things on any clause. You have to identify what it is you're actually requiring, what it applies to, what the exceptions are, and I mentioned earlier that openings are windows and doors, and that technically is called a selection because you've got a list of things that you want to include. So if I say external doors, that's two items in the applicability because it applies to anything that's external, and then you filter it down further to say it's doors. Selections, windows and doors sit parallel to each other in the collection. Anyway, you need those 4 things. And looking at the existing legislation, sometimes it's not clear even what the requirements apply to. Particularly in some, I mean, in the structural and fire legislation, it tends to be quite well written, but in terms of the accessibility stuff, it's sometimes really hard to tell what it is that fails. There's a legislation in Singapore that says that sewage pipes shouldn't run across above clean water pipes ever in a building. They shouldn't cross or whatever. And one of my colleagues I know well, and he wrote a whole paper on trying to solve this. And what he completely missed was it has to be within a space. We can have a waste pipe 5 floors up and a freshwater pipe here, and it's not a problem. It's the space that fails, and so you need to be clear about those things.
Should we have the break and return in a half an hour?
Yes. Okay.
And then we go in detail where we are. And maybe a warning, it will be quite technical, but we need to take care of the technical stuff before we can start implementing the fun stuff.
Yep. Okay, thanks, Tomi. Thanks for your patience.
Okay.
We'll see you in half an hour.
Yeah, see you in half an hour.